Hello and welcome to my session for the 90 Days of DevOps. Today we're going to be talking about how we can create a reusable library of infrastructure as code modules and hopefully help you avoid having to rewrite the same code over and over again and bring in some sort of best practices and standardization around your infrastructure as code. My name's Sam Cogan. I'm a solutions architect with a company called WTW. I'm also a Microsoft Azure MVP. And I spend a lot of time talking about cloud infrastructure, infrastructure as code, DevOps practices, those sort of things. You can find a lot of my stuff on my blog at samcogan.com or on youtube.com/samcogan, where I have a lot of videos on these sort of topics. You can also find all the source code for today's sessions on GitHub, along with a load of other code if you're interested. So what are we talking about, and why do we want to think about creating reusable infrastructure as code? If you've ever written any sort of infrastructure as code, you will have probably found that you are often writing the same code over and over. There's only so many ways you can configure a virtual machine or a storage account or whatever you're creating, and you are going to deploy those in various different settings, different scenarios, and you often just want to deploy the same sort of thing but customize it slightly for the particular scenario you're looking at. If you don't use what we're going to call modules, and you don't create reusable code, then effectively you're writing a lot of boilerplate code every time you come to create infrastructure, and there are a lot of pitfalls in doing that. The biggest one, obviously, is that it takes time. You know, you have to, if you're going to have to write this code, even if you've done it 20 times, you still are going to have to go through the process of creating that boilerplate code. Yes, you could use some things like Copilot and those sort of things to help you speed that up, but ultimately you are going to have to write that code. It was going to take you time. There's also the likelihood that what you write the first time is going to be different to what you write the 20th time. There's going to be different inconsistencies between the code. You're going to do things a slightly different way, and so you'll find that actually the way you deployed a virtual machine has changed over the months that you were writing these code, but you don't really have any record of what's changed or how it changed or why. You've just got the evolution of this code in different bits of infrastructure that you deployed over time. Creating some reusable code that allows us to use the same code in different projects. So every time we want to deploy a virtual machine, we use a module that is been defined once, and we're going to use it many times. We create that module in a way that allows us to parameterize it and pass in some variables, because every deployment is obviously going to be different. There are different names, different sizes, there are different locations, all those sort of things that are going to need to be varied. You can't be just create one set of code and expect it never to need to be tweaked or anything. So we are going to look at how we can build modules that are parameterized as much as we need, but allow us to A, save time, B, create consistent deployments using this infrastructure as code. Another reason to do this is to help the rest of your team and anyone else in your company who wants to deploy certain types of infrastructure. But perhaps they don't want to actually learn all the intricacies of how you deploy a virtual machine into Azure or AWS or whatever your cloud provider is. You can build modules that hide a lot of that complexity. You can make some decisions for your user. You can hide some of the complex configurations that are needed for your resources and present your end users with a much simpler interface to allow them to deploy that infrastructure. And it's up to you how simple that needs to be. You could make it very simple and just make a module that accepts, I don't know, two inputs, a name for the resource and a location. And everything else, you make the decision for the end user. You could make it more complicated and add more parameters. You can go as far as you want with that, but it allows you to build a sort of abstraction on top of what the cloud provider gives you to create that simpler interface for the end user. Similar to this, you can also use it to apply standards. So often you will have company standards, security standards, compliance standards, and so on that you need to make sure that your infrastructure complies with. So for example, your virtual machines always need a certain type of network configuration. That means they're not exposed directly to the internet. You need to create storage accounts that always have a certain type of encryption enabled. You need to ensure that a specific SKU size is used for any resource you're going to deploy. You only want to allow deployments into certain regions, things like that. There are lots of standards that you're going to have to comply with. Some of them will be done by default by the cloud provider, but a lot of them will be a choice that you need to make. And if you're relying on your end user to ensure that these resources are compliant out of the box, you can't guarantee that they're going to firstly understand the standards they have to use, but secondly apply them every time to the infrastructure they're creating. So you can create infrastructure as code modules that deploy resources that are out of the box compliant with all of your company standards. And so you can say to your teams, use this module and you will get a virtual machine or a Kubernetes cluster or whatever out the end of it that is fully compliant with our corporate standards. You don't need to worry about learning all those standards and making sure that they are compliant. You just need to use our pre-built module and you will get out the end of it a completely ready to go and compliant system. And finally, modules are really great where you want to share expertise between different members of your teams or company. You can put into your module your knowledge and understanding of how resources need to be created and the best practices that you know, and you can give them to people and they can deploy them and get the benefit of your expertise. But people can also look at your modules and they can see how they've been created, and they can perhaps then understand how they might want to build some things of their own. You can share that code through things, like GitHub and so on, to whoever you like. But you can also just say, I've boxed up my expertise within a module. Just take this and I guarantee you've got a well-architected set of infrastructure that will get deployed. So lots of benefits for creating reusable modules. Even if you don't care about all the rest of them, saving yourself time and not having to rewrite code every time is a big reason to do so anyway. But there are lots of other reasons as well, especially if you're in a corporate environment where you have to comply with a lot of standards and requirements around those things. So how do we create modules? If you're doing infrastructure as code, you will be doing it using an infrastructure as code language of some sort. And nearly every infrastructure as code language that I know of has some functionality for building modules or reusable code. They often call them something different, but they pretty much all exist. So here we've got a few of the more common ones. There are lots more, I haven't got on this slide here that also have functionality around this. But if we have a look, so on the Azure side, if you are looking at using ARM templates or Bicep, you've got a concept there. So ARM templates has this concept of nested templates where you can have one template call another and you can use that to create modules. Bicep has a concept, it calls modules directly, where you can create bits of code that you can then reuse and distribute. CloudFormation on AWS has modules as well. For some of the more cross-cloud providers, you've got Pulumi, which has things called component resources, and then another level in there called packages on top of component resources. And then for Terraform, again, you've got modules which allow you to wrap up Terraform code as redistributable pieces of work as well. So whatever language you are using to create your infrastructure as code, you will have some sort of technology to be able to do that. And so that's the first port of call, really, is to have a look at your infrastructure as code tool and have a look at what they are doing in that area. And that's what we're going to do now. We'll have a look at a few demos just to see how modules are created within some of these languages. Okay, so let's take a look at how we can actually create some modules in a few different languages. The first one we're going to have a look at is Bicep for Azure. And so what we've done is we've created a storage module.bicep file, and we've written some Bicep code. There's nothing particularly special about the code in here making it a module. All we've had to do is make sure that we design our interface for this particular module in this code. And by interface, I basically mean the variables that we want to pass into the module and any outputs we want to get out of the module that are going to be consumed by the rest of the code that's using the module. This is how you interact with your consumers of the module. You can change the logic inside the module as much as you want, really, but you really kind of need to make sure your interface is fairly set in stone so people know how to work with it. And if you have to change the interface in the future, obviously that's kind of a major version release and we'll need some notifications and so on. So for this module, we are just creating a storage account. But we're doing a few things in here, so an Azure storage account, we're doing a few things in here to apply some corporate standards. So if we'll start there, if you look at the actual storage resource, which is this part here, we are creating a storage account and we are enforcing that this must use a V2 storage, and we are enforcing that it must support HTTP traffic only, so turning off HTTP traffic. Sorry, HTTPS is enabled. And those are just an example of how we can sort of enforce corporate standards on there. And we're doing a couple of other things as well. So we're generating a unique name for the storage account. So storage accounts have a specific requirement for how the names are generated. They need to be unique across the whole of Azure. And so this one basically uses a function called unique string, which generates a resource name for us. And that's another way of us hiding complexity from the end user. So we are just asking them to provide this storage prefix, which is just a small text string that can be used as part of the name. And then we generate this unique string to ensure that the name is but the customer of the module doesn't need to know anything about that. They just pass in the variables. And so you can see we've got variables, what Bicep calls parameters here, to allow us to define that interface. So we're asking for this storage prefix field, and we set some limits on that in terms of how long that name can be. We're asking for the storage SKU name, which we need to define what type of storage to deploy, and we're defining a set of allowed values for that, so we can limit which options we will allow the end user to provide. So again, we are sort of forcing them down the route of these are the only options available to you. And then we're asking for the location of the resource as well, which we're allowing them to define as they want. And we generate that unique storage name, and then we create the storage account. And then the other end of our interface, we create some outputs that we provide to the consumer of the module so they can then use those elsewhere. In this case, we've got an output for the storage endpoint, which gives us the URL of the storage account. So nothing in here defines that this is a module other than the way we've laid out that code. Where it becomes a module is when we consume it. So if we go to this main Bicep file, and you can see this is where we're actually deploying some resources. And this is where we say we want to consume this module using the module keyword and pointing it at this storage module.bicep file. I've got that defined here as a local file, so it's just looking in the same folder. We'll talk a little later about distributing module files. This is just looking in the same folder for that file at the moment. And then we're passing in some parameters. So the location, that storage prefix, and the storage SKU, in this case, locally redundant storage. And that's how we consume that module. So all of the logic that's in the storage account module is hidden behind this module interface. So that's how you can do it in Bicep. We'll have a quick look now at Terraform. Now, Terraform is a little bit more, I think, complicated, but generally when you design a module in Terraform, rather than having all of those things in a single file, you can break them out into separate files for the actual code, the outputs, and the inputs or the variables. So you see here we've got this variables.tf, which has the same variables we saw in the Bicep. So the prefix, the SKU, the location, and then in the case of Terraform, we're also asking for the resource group name. Bicep is a little different in that it assumes you are deploying into a resource group when you run the deploy command, whereas Terraform needs to know that. So we're passing that in as well. We've got our main code here, which creates the storage account. And again, you can see we're doing similar sort of things. We're creating a name. We've hard coded that it's storage v2 and that HTTPS traffic is enabled. You can see that we're doing the same sort of thing. And then we've got our outputs file where again we're creating that, passing that endpoint option as an output. Then in our actual Terraform code, you can see here we're doing the same sort of thing. We are using that module keyword to point to the module file in that storage folder in this case, and we're passing in the parameters it asks for. Some of those in this case are coming from other resources, so the resource group name and location are being passed from this resource group that we create here, and then we consume that module. So again, same with Bicep. The actual module itself had no real knowledge that it was a module other than the way we've laid out that code. And then finally, we'll have a look at Pulumi. This looks more complicated because it's actually written in Python rather than the HCL type language, but similar approach. We're defining, in this case, what's called a component resource, which is Pulumi's version of a module, and we're creating the storage account, again, passing that name in as a parameter, hard coding that it's storage v2, and that HTTPS traffic is enabled. And then we define the inputs that we want to receive here. So again, we are passing in the SKU name, the location, the account name, and then the resource group name that are going to get passed in. And then when we consume it in our Python code, we are again doing the same sort of thing. We are basically telling it we wish to use this component resource. It's coming again from a file in the same directory, and these are the values that we're passing in for things like the storage account name, the location, the SKU name. Actually, don't need kind anymore. I took that one out. But again, you can see that we've simplified all of that logic for the storage account behind this facade of the module. And so that's how you can create very simple modules using those three languages. Obviously, if you use something else, if you're using CloudFormation, CDK, Google deployment stuff, you can do something very similar. We don't have time to go through all of those today. So now that we've seen how to create modules, I want to talk a little bit about creating good modules. Because it's very easy to just throw something together and put out a module, but there are some things you consider when creating modules to make sure that you're actually creating good modules that people are going to want to use. So the first things first, generally you want to make modules do one thing as simply as possible. So it can be tempting to create kind of super modules that will do every single thing that you want. Let's say you've got a piece of software that has a whole load of infrastructure. You want to create a module that deploys all of that in one file. That limits the reusability and it makes it harder to work with. If you've got a module that does lots of different things, it can only really be used for that specific use case that you created it for. Whereas if you create a module that does something like, I don't know, create a storage account, then anybody who wants to create a storage account can use that module. If you then want a storage account and a virtual machine, you can have two modules and people can consume those together in their file and get both of those without you having to create a separate storage and VM module. Now, there's nothing to stop you taking modules and combining them together into another module. Modules can consume modules. You want to avoid that too much because it can get very complicated, but it is possible to do that. So if you do want some kind of super module, you could go down that route, I suppose. But generally, you want to keep your modules as simple as possible and have them do one thing. Now, it doesn't mean they can't deploy multiple resources. So say for example, you wanted to create a module that deploys a Kubernetes cluster. And that generally is going to have a few different things that you deploy within it. You're going to have some compute resources, you're going to have the AKS resources, maybe some storage account stuff to go with it. But you want to make it as focused as possible. So generally, if you deploy a Kubernetes cluster, it's going to go into a network. Now, you could create that network within your Kubernetes module. But what if somebody's already got a network and they just want to deploy a Kubernetes module into it? A Kubernetes cluster into it. They now can't use your module because it expects to create their own network and they can't do that. They want to use their existing one. So in that scenario, you probably want to keep your Kubernetes cluster module as focused as possible with things that just are directly consumed by Kubernetes and that wouldn't need to be created externally. And then anyone can consume that. You might then have a separate network module that creates a network, but you can do those in two separate modules. So keep your modules focused. When you're creating a module, you want to provide parameters and ways for people to vary what goes in and out of the module. But keep it simple. Don't provide huge amounts of options because then your module becomes really unwieldy. One of the benefits of the modules, as we talked about, is to hide complexity. But if you're presenting lots of different options that people need to know what the appropriate values are and what they're going to want to use for, your module then becomes harder to use. And at some point, you have so many parameters that they may as well have just used the original resource in the first place. So focus your modules, make some sensible choices for people if they are not something people are likely to want to change, or if they are things that are set by policies and standards. Hard code those in your modules and only offer people choices where it's needed. You also want to make sure that your module is adding value. There is no point just creating a module that wraps the sort of built-in resource and doesn't do anything else. Let's say an Azure resource group. A resource group is just basically a folder you put resources within. You could create a module that creates a resource group, but a resource group really has 3 or 4 options, names, location, well, that's about it really, tags maybe. So there's nothing special you can do with a resource group. So there's no point creating a module wrapping that because it's not adding any value. Whereas, when you're creating a Kubernetes cluster, for example, they can be really complicated things to deploy. And by creating that module, you are hiding some of that complexity. You are allowing you to deploy your cluster within compliance with your standards and so on. There is value to that module existing. You want to version your modules. People are going to consume those modules and they are going to rely on them to deploy their infrastructure. If you suddenly just change the code and it works differently, or you add new properties to your interface and they can no longer run their module, they're going to get pretty annoyed. So version your modules so that they know what version they're on and they're able to upgrade at their choice rather than yours. And most of the tools for deploying modules within an infrastructure as code language have a way you can version them to get them delivered to your users. Similarly, make them easy to obtain. People aren't going to use them if they have to go through a complex process to actually get hold of your modules, or every time they run a deployment of their code, they have to do some sort of work to go and get those installed. And we're going to talk in a minute about how you can deliver those modules, but you want to make sure that people can obtain them easily. You also want to make sure you update them. If you have a module that does a specific thing and it's tied to a specific version of your cloud provider's setup, and they introduce some more features or additional properties that you can configure, and your module isn't updated, people are just going to go back to using the default resource because your module doesn't do what they want. They're not going to wait for you to sort that out. If you aren't updating your modules, they will assume they're dead, and that's one way to just get people to give up on your modules. If you're going to start using modules and creating them, start with something simple. Don't try and do something really complicated as your first module. Create something that has value and that people are going to get benefit out of, but make it a fairly simple resource. Make it something that doesn't have a huge amount of options. Like we know with storage account was the one thing we looked at there. Storage is very easy to deploy. But something like that is easy to start with, get practice with creating modules, and then move on to the more complicated things. Make sure you create good documentation for your modules as well. Although you might have some IntelliSense and so on, if people can't see how to use your module, what values they need to provide, what are the acceptable values for the storage SKU, those sort of things, people aren't going to use them. So make sure you've got documentation that people can read easily to see what the module is going to do. And then finally, evangelize and engage. People aren't going to use your modules if you don't tell them about them, or tell them why there's benefit to doing it. So make sure people are aware that they exist, that you're telling them what the module's for, why they want to use them, what benefit it brings them, maybe even just why they have to use them. Maybe it's a corporate decision, but whatever you want to go down that route, but make sure people are aware of what they're for. So I mentioned before, you want to get these modules into the hands of your end users. Obviously, you saw in the demo, you can just put those files in a folder and you can consume them that way. But that isn't really sustainable for where you've got teams of users who want to access resources, or you want to distribute them throughout the company and so on. That's not going to work. You can obviously put them in a Git repo and people can clone Git repos with them as well. That's one way of doing it. But a lot of the infrastructure as code languages will provide a way of you actually distributing those. So for both ARM templates and BISEC, you've got something called template specs, which allows you to create a registry of those modules. BISEC also has a module repository feature now where you can actually put them in a container registry and consume them from there. And that allows you to then have a centralized storage of those modules, which you can then have people put the URL of in their code, and it will go and fetch those modules for you. So you can maintain a single source of truth and everyone gets the modules. It makes it really easy to consume them. You can version using that, so when you release a new version, you can push it to your module repository and people can then consume it when they want to. Similarly, for CloudFormation, there is the CloudFormation registry, which allows you to create a repository of those modules. Pulumi, because it's based on writing code using actual languages like Python, C# and so on, you can use the native distribution mechanisms that come with those languages. So for C#, you can use NuGet. For TypeScript, you can use NPM. For Python, you can use PyPy and so on to deliver those. Makes it really easy, particularly if you're working with developers. And then for Terraform, you can reference a Git repository within your Terraform code to get the modules, or you can also use Terraform registry as part of Terraform Enterprise, or obviously there are some third-party tools like Spacelift and so on that can do similar sort of things and give you a module registry. All of these allow you to have that single source of truth, so you only have to push out your new releases to one place, and then everyone who's consuming them can grab them from there. And it makes it really easy to get started if you're spinning up some new infrastructure code. How do I get the corporate modules? Oh, just pull them in from this registry or this URL. So really recommend you look at doing that if you're looking to get your modules into basically anyone else's hand other than your own. So finally, just some real world examples of where you might want to create some modules and that might bring benefits to you. So for example, virtual machines. VMs are the mainstay of a lot of cloud providers, but they have so many different options you can configure in how you deploy those VMs. how your storage is set up, how the networking is done, which operating system you use, which configuration, which security settings you apply, and those sort of things. So you can create a module that deploys virtual machines and make a lot of those choices for the user, create your corporate standards and so on, and that hopefully will simplify that process. Similarly with Kubernetes clusters, so many different options. If you're new to Kubernetes, if you're a developer, you're trying to get your developers sort of get started with using Kubernetes, the way of deploying the cluster is so complicated that they don't, they can't do it. They're never going to get going with that. So you could create a module that makes it very easy to deploy a Kubernetes cluster with a load of defaults decided for the end user. Network layers. So maybe you've got separate teams that deal with how networking can be configured within your infrastructure. They could create a module that defines how to create a network, how to hook it up to the corporate network, how to do peerings and those sort of things, how private endpoints should work or other integration with services. So you could create a network module that does all that for you, and the end user just consumes it and says, I want a network. They get one that's ready to use and already hooked up to the rest of the corporate network and so on. Lastly, a configuration module. This is a really interesting one, and it's something I use quite a lot, but it doesn't really create any code. But when you create infrastructure within your cloud provider, there are usually lots of different configuration settings that you want to be able to set on resources that are perhaps standard across your company or your bit of the company, your department. So things like firewall IP rules. So, your corporate network outbound IPs that you want to allow into your resources, naming conventions for resources, certain permissions that need to be applied to all resources that are standard across the company, and so on. You can create a module that essentially just takes some inputs and uses those to create some outputs. It doesn't create any infrastructure in between, but those outputs are all your configuration settings that can then be consumed by all the teams. So if you need a way to actually define configuration across multiple teams and so on that can be consumed as a module in an easy to consume way, that can be one way to do that. Now, there are tools that will do some of that for you. So if tools like Hyra from Puppet or ESC from Pulumi that can do some of that for you as well. But just creating a module can be a simple way of doing that. And if you're interested in that one, I do have a blog article that talks about it in a bit more detail. I'll put a link with a video. And that's it. I hope that was a useful session. I hope it's encouraged you to go away and start looking at how to create modules and how to reuse some of your infrastructure as code. If you have any questions, I'm always happy to answer those. Send me a message on Twitter or X now, or have a look at my website as well. But hopefully you enjoyed that, and I hope you enjoy the rest of the sessions in the 90 Days of DevOps as well.